Alright, test number 2, question number 11. A pair of sunglasses is dropped from a 200-foot building. The height of the sunglasses, h in feet after t seconds, is given by the equation h minus equals negative 16t squared plus 200. Question A asks us to find out the height of the sunglasses after 2 seconds. Well, the way we can do this is we can obviously plug in uh, t or 2 for t into the equation and solve it, or we can even use just our graphing calculator to solve this also. If we bring up the graphing calculator, we're going to go ahead and substitute our equation in. So we got negative 16x squared plus 200. Now before we graph this, we got to make sure our window is set to an adequate level. So we're going to change our window from negative 10 to negative 5. And we'll go down to positive 5. And then our scale will stay the same. Then our y will go down to negative 30 just so we get a good look at it. And we need to go up to at least 200, so let's go up to 220. And we'll go by tens. So now that when we graph the equation, we can see it's a parabola that opens down. This is the building, and this is actually be the location of the 200 feet up in the air. Now to find out how high it is after 2 seconds, I can also use my table function, but I can just use my trace key. And I'm going to plug in my x value of 2, hit enter, and you can see right there after 2 seconds, my the height of the sunglasses is 136 feet. So the answer would be 136 feet. And just to double check on our table, we can also go to our table and find that out. So we just, as I like you to see, right here at 2 feet, it's 136 feet. At 2 seconds, it's 136 feet up in the air. Now the question is how long it would be before the sunglasses are 100 feet in the air from the ground in part B. And the way I do that is I'm going to graph another line at 100 feet. 100 feet, and this I'm going to use my intersection button to take a look at that. And what I'm interested in is the intersection right here, the positive intersection. So I'm going to use my second calc, option number 5. I'm going to get a little closer to the intersection so I get a good read. Enter, enter, enter. And it tells me at 2.5 seconds, the sunglasses are 100 feet in the air. So my answer for part B is 2.5 seconds. And finally, for part C, it says how long will it take before it hits the ground? Well, that's simple. The ground is at 0, so I'm going to graph a line at 0. And you can see there's my parabola, and of course I'm graphing a line right on the x-axis. And of course what I'm interested in is this intersection point right here. So after I finish this graphing, I'm going to use my second calc trace to get my intersection there, and I'll find out what that line is. So I do second trace, option number 5, and I need to get closer to that intersection, so I get a little bit over there more. And enter, 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 and it's approximately 3.5355339 seconds. We'll round this off to just 3.54 seconds. So 3.54 seconds roughly is how long it takes for the sunglasses to hit the ground. So that's how I do number 11 on the test.